Hi, and welcome to Chapter 14, Challenge Problems. So let's go ahead and get to it. Our first problem here, we have a firm in a competitive market has the following cost structure. So here we see average total cost. Remember, that's total cost divided by quantity. Okay. If the firm's fixed cost of production is $3 and the market price is $10, how many units should the firm produce to maximize profit? Okay, so the first thing that I'm going to do here is to figure out what total cost is. And so we know that total cost divided by quantity equals average total cost. Here they gave us the average total cost and we have to back out the total cost. So for the first one, we have 10 is equal to total cost divided by a quantity of 1. And so if we cross multiply, we get total cost is equal to 10. So I'm just going to make a new column here. Total cost is equal to 10. For the second one, we have 8 equals the total cost divided by 2. So I'm going to go ahead and just cross multiply here. Total cost equals 16. For the third, we have total cost is average total cost is 7 equals total cost divided by 3, because 3 is our quantity. Set them equal to each other. We have total cost is equal to 21. 21. For the fourth quantity, we have $8 is equal to 4. Total cost divided by 4. So we have total cost cross multiplying equals 32. For the fifth, we have $10 equals total cost divided by 5. So we have total cost equals 50. Okay. From that, I can then look at, say, okay, maximizing profit. Where does maximizing profit happen? It's where profit is always maximized, where marginal revenue equals marginal cost. This is a perfectly competitive market. So therefore, we know that the market price is going to be marginal revenue is going to equal $10. We don't know yet what marginal cost is. So let's go ahead and calculate marginal cost. Let me get to a different color here. And I'm going to go ahead and put a marginal cost in here. So as we change from 0 to 10, okay, and then from 10 to 6, that is a difference of 6. From 16 to 21, that's a difference of 5. From 21 to 32 is a difference of 11, and from 32 to 50 is a difference of 18. Our marginal revenue is 10. Where are we closest? 1, 2, 3 units. So if marginal revenue equals 10, marginal cost is equal to 11. So it's right in between 3 and 4 units, so we're going to say 3 units because it's closer. So the right answer here would be C. In our second problem, we know that we're given a competitive firm that sells its output for $40 per unit. Remember that in a perfectly competitive market, the first information we can glean from this is that price is equal to marginal revenue, which is equal to average revenue. In this problem, that's all going to be $40 per unit. Okay. When the firm produces and sells 100 units of output, so 100 of output, average total cost is $23. So average total cost is equal to total cost divided by quantity. Here they're telling us at 100 units, at a quantity of 100, our average total cost is $23. And we're trying to solve for total cost, and our quantity is 100. So I'm going to go ahead and cross multiply, and I get the total cost at 100 units is equal to 2,300. The next information that I have, I'm going to go ahead and erase that part because, yeah, okay. The next information that I have says that my firm produces and sells 100 units of output. Average total cost is $23.15. So average total cost, again, total cost divided by quantity. And this is at 101 units. Average total cost is $23.15 equals total cost over 101. I'm going to cross multiply. When I do, I get the total cost is equal to $2,338.15. Now, I know the marginal cost from the problem. And now what I need to do is to find marginal cost as we move from quantity of 100 to quantity 101 as we add that additional unit. So marginal cost is just the change in total cost divided by the change in quantity. So I take my original total cost of 2,300, look at the change, 2338.15, and then divide that by the change in quantity from 101 units, from 100 to 101. Okay, so we have negative 38.15 over negative 1. And if we multiply both the numerator and the denominator by negative 1, that becomes 38.15 over 1. And that gives us 38.15. That's going to be our marginal cost. To get our profitability, we're going to take our marginal revenue minus marginal cost. So our marginal revenue is $40. Our marginal cost is $38.15. So the change in profitability, it was an increase because marginal revenue is greater. So it's an increase of $1.85. So the correct answer here would be D. Our third problem, if Billy's Build-A-Bear Workshop is a competitive market. Okay, so we know in a competitive market the price equals marginal revenue, which equals average revenue. Okay, and we have a couple of selections we can choose from. The price of that product depends on the quantity of that product that they produce and sells because the demand curve is downward sloping. No, remember that in a perfectly competitive market, so I'm going to disprove A by going in a perfectly competitive market, the demand curve is perfectly flat because price equals marginal revenue. So we know it's not A. B, Billy's Build-A-Bear Workshop total cost must be a constant multiple of its quantity of output. Well, a constant multiple would mean that the total cost curve is also horizontal. That might be true in the long run, but not in the short run. So B is incorrect. C, Build-A-Bear Shop total revenue must be proportional to its quantity of output. Yes. So we know that its revenue, total revenue, is equal to price times quantity. So as quantity increases, the price remains constant. That means that total revenue will increase. C is the best answer so far. Buddy's Build-A-Bear Shop total revenue must be equal to its average revenue. Remember, perfectly competitive market, price equals marginal revenue, which equals average revenue. And total revenue is equal to price times quantity. Because price is the same as marginal revenue, we know that that one is incorrect. So the right answer here is C. Okay. Ford looks at, we have two graphs. We have graph A and graph B. Assume that the market starts in equilibrium at point W. So we're right here at point W. An increase in demand from D0 to D1. So D0 is shifting out to D1, okay, will result in, okay, so this is a perfectly competitive market. When the demand for the market shifts outward, then that causes an increase in price to P3. Because this is a perfectly competitive market, we can easily see that when the price increases, that's going to cause the supply curve to increase because it's really easy to enter this market, really easy to exit this market. So the supply curve will shift from S sub 0 to S1. That will lead us from Y right over here to point Z. So I want to think long term what's going to happen in this market. A new equilibrium at X? No. An eventual increase in the number of firms in the market and a new long-run equilibrium of Z? Yes, that sounds right. Rising prices and falling profits for existing firms? No, it does rise, but the profits will rise until new entrants come into the market. Falling prices and falling profits? No. So B here is our best answer. Cold Duck Airlines flies between Tacoma and Portland. The company leases planes on a year-long contract at a cost that averages $600 per flight. Okay, so is the first thing I want to think about $600 a flight? It's a year-long contract. That sounds like a fixed cost to me. So the fixed costs are going to be $600. Other costs, fuel, flight attendants, and so on, amount to $550 per flight. Those are variable costs. Currently, Cold Duck's revenues are $1,000 per flight. So total revenue is going to be $1,000 per flight. All prices are expected to continue. If it wants to maximize profit, Cold Duck Airlines should. Well, I've got some information here, but I want to know how much its total cost. So if I can take my fixed cost, add my variable costs, I end up with $1,150. If my total revenues are $1,000, then each time I fly, I'm actually going over, I'm losing $150, okay? Now, here's the question. Should I drop the flight immediately? Well, if I drop the flight immediately, I still have to pay the fixed cost of $600. So, would I rather have a loss in the short term of $150, or would I rather have a loss of $600? And so the answer to this is I'd much rather have a loss of $150. So I'm going to continue. Nope. Continue the flight. Well, right now that's probably the best option. Continue flying until the lease expires, then drop the run. I like that best of all. Drop the flight now, but renew the lease if conditions improve. It says we're expected to continue, so I don't think conditions are going to improve. So here, the right answer would be C. Okay, number 6 says, suppose the firm's operating competitive market has the following cost curve. So we have marginal cost, average total cost, and variable cost. When the market price is P2, okay, so I'm going to go ahead and put in, try to draw a straight line. This is marginal revenue equals price equals average revenue. Okay. A profit maximizing firm's losses can be represented by what area? Well, if this is my average total cost curve up here, this curve right here, and this is where my price is at, and I'm going to produce where marginal revenue, marginal cost meet to minimize my losses. If I follow this straight up, then I follow it over, I'm going to have this amount of loss. Now, is there something here that tells me that? Well, I've got a P4 and P2. No, that's some of it, but it's not all of it. P2 minus P1, no, that's not even right. At a market price of P2, the firm earns profits. No, it doesn't, because we're below the average total cost curve. At a market price of P2, the firm has losses. Agreed. But the reference points in the figure don't identify the losses. I would agree with that one. Okay. 7 says the table represents a demand curve for a perfectly competitive market. So they gave us price. Again, price is equal to marginal revenue, which is equal to average revenue. Just some things you want to look at in this market. From this firm, the marginal revenue from selling the next unit is what? Okay. Well, the marginal revenue from selling the next unit, because price is constant in a perfectly competitive market, is going to be $15. Because it's going to be 15 and 6, 15 and 7, and it's going to continue. Because the demand curve in a perfectly competitive market is horizontal. Our 8th question says, suppose a firm in a perfectly competitive market earned $3,000 in total revenue and had a marginal revenue of $30 for the last unit produced and sold. What is the average revenue per unit and how many units were sold? Okay, so they're telling us that total revenue, we know, is equal to price times quantity. Okay, we have $3,000 in total revenue equals price times quantity. They also told us that we have a marginal revenue of 30. Marginal revenue is equal to price, which is equal to average revenue in a perfectly competitive market. They're telling us that the marginal revenue is $30. That means the price is $30. That means average revenue is $30. If we can take the information about marginal revenue and put it in here for price, we get total revenue is equal to, of $3,000, is equal to $30 times quantity. We divide each side by $30. We end up with a quantity of 100 units. So we have a price of $30 and a quantity of 100 units. Okay. Our last question says the information below, a perfectly competitive firm that sells its output for $40 per unit. Okay, so price equals marginal revenue equals average revenue equals $40. Firm produces and sells 100 units of output. Average total cost is 23. Average total cost is equal to total cost divided by quantity. Our average total cost is $23 equals total cost over 100. Cross multiply, and I get total cost at 100 units is equal to 2,300. Looks familiar because we just did this problem. Okay, next step, average total cost. is equal to total cost over quantity. And our average total cost is $23.15 equals total cost over 101. Set that over 1, cross multiply, and we get total cost is equal to $23.15 times 101, which is going to be $23.38.18. So we have $23.38.15. Our marginal revenue is equal to $38.15, the difference between our total cost at a 101 and our total cost at 100. I'm sorry, that should be our marginal cost, sorry. Marginal revenue is equal to $40. Okay. Should the firm increase its output to 101 units? As long as marginal revenue is greater than marginal cost, we're going to increase output. So we're going to increase output. We're going to get rid of those. Yes, totally. Why? Because marginal revenue exceeds marginal cost. Okay. So that's the end of these problems. If you have any questions, don't hesitate to contact me. Thank you.